We're continuing Unit 6, Introduction to Exponential Functions. We'll be covering lessons 15 and 16, Reasoning and Exponential Graphs, and Functions Involving Percent Change. Turn in your workbooks to page 272 and complete the bridge. Take a minute to look at each of these functions that represent the amount in different bank accounts after T weeks. So T is time, and we're counting our time in weeks. Open up Desmos or use a graphing calculator to create a graph of each function, and then describe in your words how the money in each account is changing week by week. And then how do you see this in the graph? This is what I put into Desmos. Look at A of T. That's going to be the blue line. A of T equals 500. So if you change the function notation to y equal 500, you're just going to draw a straight line, horizontal line through y, parallel to the x-axis. For B of T equals 500 plus 4t, this is in the form y equals mx plus b. B is where the initial amount that we start with. And if you notice, each of these starts with an initial amount of 500. So they're all going to originate on the y-axis at 500. But this is a linear equation. The slope is 40. The intercept is 500. That's going to be the black line. It's a positive slope. It's increasing by 40 each time we go up 1. C of T equals 500. We're going to start with 500, but this time we're going to go down 40 each time. Okay, so this is going to be a negative slope. But these are linear equations because we're adding or subtracting. We're not multiplying. D and E are going to be curves. They're going to be exponential. One is growth. Whatever has the growth factor that's greater than 1 is going to increase. It's going to go up. So that's going to be that blue line where it's curving up, starting at 500, increasing rapidly. And then 75% is the same as 3/4. So this is going to go down. It's going to start at 500 and it's going to go down. It's going to drop down. This is the green line. You can see the key here. I did this in Desmos. So let's describe this in words. All of the accounts start with $500. A does not change. That amount stays constant. $500 in the bank account, it just stays 500. B increases by $40 each week. You can see the output of the graph increasing by 40 with every increase by 1 of the input. That's the black line. C decreases by 40 each week. You can see the output of the graph. It's going to go down by 40 each week. D increases by a factor of 1.5 each week. You can see the output increasing by a factor of 1.5. It's going to go up. It's really kind of hard to see in this because I haven't zoomed out enough, but I needed to squeeze this in so I could put this on the slide. But it's that blue curve that's going up. And then finally, E decreases by 3/4 or 75% each week, 75 hundredths each week. You can see the output decreasing by a factor of 0.75 for each increase by 1 of the input. Now turn to page 272 and complete the warm-up. 4 functions. Which one doesn't belong? Pick one of these and explain your reasoning. If you chose function f, 8 times 2 to the n, we're multiplying and we have an exponent n. We can replace the n with x and the function notation f of n with y. Y equals 8 times 2 to the x. The initial amount would be 8 and the growth factor would be 2. f is the only one that doubles when n increases by 1. Okay, I have a growth factor here of 8. This is a linear equation, and this growth factor is 1/2, so it's actually going to be decaying. If you chose h, function h, that's card C, this is the linear equation. You can replace the input n with x, the function notation with y, so this would be y equal 2x plus 8. Y equals mx plus b. So this is the only one that's linear. All the others were multiplying by the same number over and over again. If you look at function g, it's the only one that does not have 8 for the vertical intercept. 8 is the growth factor, 2 is the vertical intercept, or the initial amount. All the others have 8 as a vertical intercept, even the linear, because b, what we're adding, that constant, is where it crosses the y-axis. Okay, and then finally, let's look at function j. It's the only one that is not increasing. It's going to be decaying, so it'll be going down in this direction. The others will be going up. These two exponential equations, this linear equation is even a positive slope. Slope is 2. All right, page 273, activity 1, value of a computer. Here's a graph representing an exponential function f. The function f gives the value of a computer in dollars as a function of time, x, measured in years since the time of purchase. All right, so let's highlight what we've been given. We have function f, that's the value of a computer in dollars as a function of time. Time is x, and we're measuring that in years. All right, so the initial purchase price when we start is $400. Now, what is the value of f when x is 1? So we're going to go over 1, and I don't see any point there. I see 2. If I move over 2, we're going from 400 to 100, and 1 should be right here somewhere. So I'm going to go up from 1, touch the line, move over to the left. So f of 1 is 200. Okay, now that we know what that 1 increment is from 0 to 1, what is that relationship from 200 to 400? How much was remaining? 200 over 400. 200 is half of 400. 2 over 4 is 1/2. So our decay, we're decaying by 1/2. We're going to be multiplying 400 times 1/2 to get to 200. And then 200 times 1/2 to get to 100. And then 100 times 1/2 to get to 50. That's where this 3 is going to be. And then half of 50 is 25, and so forth. All right, what is the meaning of f of 1? This is the value of the computer after 1 year. Remember, input is our x, and input is always time. How does the value of the computer change in each y? So we're looking at the y-axis right here. Let's understand what that question is asking. Okay, if we look at each y, we move up an increment of 1. It's losing half of its value each year. You could also say it's keeping half of its value each year. An equation that defines f. So we're going to start with f of x. The initial equals the initial amount equals 400 times that decay factor 1/2 raised to the x power. Okay, you could also write 1/2 as 0.5. And then f, whether the value of f will reach 0 after 10 years. So you could put this function into Desmos. You could slide along on the x-axis to 10 and then go up and see if y is going to be 0. But it will not. After 10 years, the value of the computer will be a little less than 40 cents. Okay, take some time and put that into Desmos, this function right here, and then play around with it, or you could use this function. They're both the same. Alright, let's turn to page 274. On 274, here are the graphs of two exponential functions. For each, write an equation that defines the function and find the value of the function when x is 5. Alright, take some time to look at that and then come back and compare. Okay, our initial amount is 5. Look at the y value. It's crossing the y-axis at 5. It is an exponential function, so write f of x equal 5 times, how do we get from 5 to 15? What are we doing? We're multiplying by 3. So times 3 to the x. And then this one, f of 5 equals, no, I'm still looking at a. We want to know what x is. We want to know what the function value is when x is 5. So we're going to replace x with 5. So 3 to the 5th power. Put this in your calculator. Multiply by 5, and you should get 1,215. All right, now let's look at function b. We're going to start initial amount at 20, and then it's going down from 20 to 5, but that's an increment of 2. This right here would be -1. So let's see, it's going from 40 to 20. That looks like half. 40 divided by 2 is 20. 20 divided by 2, our y value should be 10 right here. And then half of 10, our y value should be 5. So it looks like we're decreasing each time we go down 1 unit. We're decreasing, we're taking 1/2 of that initial amount. So 20 is our initial amount times 1/2 raised to the power of x. Or you can write 1/2 as 0.5. All right, replace the exponent with 5. Put this in your calculator. So 1/2 to the 5th power times 20 is 0.625. All right, practice using your calculator. The more you practice, the better you'll be when you get ready to take our test next week. All right, activity 2. Here are graphs representing two functions and descriptions of two functions. Function f is the area of a wall that is covered by mold, A, in square inches, and it's doubling each month. Function g is the area of a wall that is covered by mold, B, in square inches, that triples each month. Okay, which graph represents each function? Label the graphs accordingly and explain your reasoning. So if you've been really slowing down, listening to the videos, you should be able to tell which one's increasing quickest. Function g is solid, and function f is the dashed line. Okay, function f is doubling every month. Okay, that's the dashed line. So it's gonna start here and then go up. I'm sorry, start here and then go up steeper. Then function g. Function g is tripling. Let's look at that for a minute. Doubling function f. Function f is the dashed. All right, so that's it. I had it backward. All right, function f is doubling. So that's going to be the one, the dashed one. It's not going to increase as rapidly. Function G is tripling. It's going to go up steeper. When the mold was first spotted and measured, was there more of mold A or mold B? So the highest amount is that dotted line. So that's function F. That's mold A. Okay, how do you know? Because of the graph. It starts higher. The y-intercept is higher. What does point PQ tell us? Point PQ tells us the time that the amount of mold was equal. At P, the mold for A and B were the same. Let's turn to page 276. Go through the summary and glossary. Highlight important functions. Oops, that's not my highlighter. Vocabulary, anything that we've gone over that you need to reinforce. Go through that slowly and also use that along with your study guide before we take our test next week. All right, complete the cool down. The cool down is going to be in Canvas. Here are two graphs that represent the function f, given by f of x equals 10 times 2 to the x. So we start with the initial amount of 10, and we're going to double it each time. Is b greater than or less than 2? Explain how you know. All right, b is greater than 2. Now here's some sample reasoning. Don't copy my answer because it will not be correct if you just copy. This is to get you started thinking. The graph of G starts off below the graph of F. Okay, how do we know? Let's see, the graph of F starts at 10. That's the green line. The graph of G is the red line, so that starts below. So this is going to be below 10. Okay, this is going to start at 3, and this one starts at 0, 10. Okay, but later it surpasses the graph of F since G grows more quickly than F. So this growth factor must be larger than 1, and also larger than the growth factor for F. Write an equation that defines G and show your reasoning. All right, how do we get from 3 to 12? You multiply by 4. Okay, and then 12 times 4 is 48. So the growth factor is 4. Okay, we start at 3. That's our initial amount. On the y-axis, the y value is 3 times 4, our growth factor to the x. F and G represent the number in thousands of social media followers of two organizations as a function of years since 2010. What does the intersection of F and G mean? This represents time in the years since 2010 when the two organizations have the same number of followers. Okay, I'll let you copy that down, but write it in your own words. Try to understand what exponential functions are doing. All right, warm up. Turn to page 283. All books at a bookstore are 25% off. Priya bought a book originally priced at $32. The cashier applied the store-wide discount and then took another 25% off for a coupon that Priya brought. There was no sales tax. How much did Priya pay for the book? Show your reasoning. Okay, Priya paid $18. Okay, write this down, and then as you're writing it down, follow the thought process. All right, we start with $32. Okay, we're taking off 25%. 25% is 1/4. Subtract 1/4 from 1, you get 3/4 or 75%. Okay, so if we start at $32, multiply by 3/4 or 75%, 0.75. 2 times, we're left with 18. All right, strategy 1. We can take 32, multiply by 25% or 0.25, and then subtract from 32. Or we can simply take 32 and multiply by 3/4. And that tells us what's remaining. So remember, decay, we're going to take that amount. 25% is 25 over 100. That reduces to, you can write it as a decimal, 0.25, or you can write it as 1/4. But you got to subtract that from 1 to get the amount that's remaining. All right, these are just 2 ways to calculate. All right, now we're going to do an ed puzzle in class. We'll review doing that together, or some other activity. All right, let's look at activity number 1 on page 284. Tyler has a full tuition scholarship for the first year of college. To purchase books, they obtain a private student loan for $450 that charges 18% interest. The loan is automatically deferred until 6 months after their final college semester, but it accumulates interest on the unpaid balance. Tyler makes no payments during the first year. How much will they owe at the end of 1 year? Show your reasoning. All right, we're going to take that initial amount, 450, times, now this time we're charging interest, so we're going to add that 18%, and percent means over 100, so it's going to be 1800ths. We're going to add that to 1. That 1 was kind of wiggly. So 1 plus 0.18 is 1.18. Multiply that to 450 and you get 531. Okay? Assuming Tyler continues to make no payments to the lender, how much will they owe at the end of 2 years and the end of 3 years? Okay? So we're going to take that, this same equation, and then we're going to raise this 1.8 to the second power, put that in our calculator. We should get about $626.58. And then we're going to raise it to, let's see, the power of 3. Okay? And then that should be $739.36. All right, so write this down. This is how you do the calculation. Just need to remember, when we're charging interest, we're adding on. So we need to take that 18%, write it as 0.18, add it to 1, and then multiply that to the starting amount of 450. All right, to find the amount owed at the end of the third year, Tyler wrote 450 times 1.18 times 1.18 times 1.18. Does this expression correctly reflect the amount owed at the end of the third year? What do you think? Write something down and then come back. Yes. This is the same as 450 times 1.18 to the third power. They're just expanding it, writing it out. Write a function rule in the form of f of x equal a times b to the x for the amount Tyler owes at the end of years without a payment. So this is going to be f of x equals, what is the initial amount? 450. And what is the growth factor? 1.18 raised to the x power. Activity 2, income from movie ticket sales. The weekend a new movie was released, it had a total income of $270,000. The weekly income for each week after initial release decreased by 13%. So this time we're going to subtract the 0.13, subtract that from 1 because it's showing a decrease. You subtract that from 1, you have what's left over. That's going to be 87%. 100% minus 13 is 87%. You can write that as 0.87. That's what's remaining. What is the weekly income 1 week after the initial release? Okay, we're going to take that 87%, raise it to the first power, multiply it times the initial amount, 270. Okay, write that function rule. The initial amount times 87%, whatever's left over after we subtract 13% from 1, or 100. Multiply that together for the first week, you get $234.9 thousand. For the second week, raise 87%, 87 hundredths, however you're going to say that, to the second power. Multiply it times 270, and you'll get $204.363 thousand. The third week, take your initial amount times 87% to the third power, and you should get $177.79581 thousand. Practice doing that in Desmos. Compare your answers, and then kind of see if you need to round and where to round to. The computer doesn't always tell you, or the test doesn't tell you where to round to, and so take a look at this, practice with your computer, and get used to putting an answer in. All right, what does each number in the function rule mean? $270,000 is the initial income. 87%, I'm reading it as percent, you can read it as 87 hundredths, is the amount that's left from the previous week. All right, activity 2, income from movie ticket sales. Explain what each number in the following function rule means. All right, the f of x equals 270,000. 270,000 is the initial amount, and then 87% or 87 hundredths is the amount that's left after the first week or second week. Each time, this is going to be the amount that's remaining. When given a 13% decrease, why do we multiply by 87%? It's because we have to subtract, when we're decreasing, we have to subtract this from 1. In this case, percent, subtract from 100. Go through the summary and glossary, and then do the cool down. Your practice problems will be page 277, 1, 2, and 4, page 288, 1, 3, 4, 6, and 7.